Okay, so this is on chapter 10, and that's on correlation. So here is a chart of death rates out of 100,000 people for 6 ethnic groups, and we will be focusing on the chronic heart disease, or sorry, not chronic, coronary heart disease. So, using the data above, determine with 95% confidence if there's a correlation between height and coronary heart disease, not chronic, using the p-value method. If there's a correlation, graph the line of best fit and find the expected death rate due to coronary heart disease of a person who is 171 centimeters short, not tall. That's a funny joke, Paul, good job. Remember, the rates are out of 100,000. So let's start by entering in all the data into our calculator, starting by putting all the height into one column, and then all the coronary heart diseases into another. So let's start by beginning and stating our hypotheses. So we got the null hypothesis is that rho equals 0, and our alternative is that rho does not equal 0, which will mean it'll be fun. Okay, so now we're going to have to find the test value. So I've drawn a graph, or not a graph, I've drawn that. And so now we have to find the test value. In order to do that, we need R and N. N is just going to be the number of samples. So let's see, that's 1, 2, 3, 4, 5, 6, N equals 6. But in order to find R, we're going to have to take our calculator, TI-89, go into test list editor where we entered in the data earlier, and go to F6, and then lin reg t-test, which is A. Press enter. Then we want to enter in the list that we put the data into. Mine are list 5 and list 6. Frequency of 1 does not equal 0. Y1 of X, and then we're just going to hit calculate and hit enter. And that gives us, let's scroll down, find R. That gives us a t value, but we're going to do this the long way too, just so we know how to do it. R is going to equal 0.854. We'll just go to 3 decimal places. Then we're just going to plug in R and N into the equation I have there. So t equals R times the square root of n minus 2 over 1 minus R squared. And so let's just plug that in. 0.854 times the square root of 6 minus 2 over, oh shoot, we need 1 R squared. So 1 minus, calculator actually also gives you R squared, so R squared equals 0.729. 1 minus 0.729. And that equals, let's see, 3.276. Make sure you check that with the calculator because the calculator is a little bit more accurate. But so 3.276 for the t value. We just want to plot that right there. That'll be good. 3.276. Shade in the p value, and that's going to equal. The calculator gives it to you 0.0306. Let's go 4 decimal places on that one. And since it's two-tailed, just draw this over here. So this is actually 0.03 is actually the area of both of those. Okay, so point alpha is, here, look right here. confidence is 95%, so that means alpha equals 0.05, and that is greater than 0.0306, so we can reject and say that there is a correlation. So we say that, we're going to make a statement and say that there's enough data to claim that there's a correlation between height and death rate due to CHD with 95% confidence. Now we're going to find the line of best fit, and so stay on the linear regression t-test that we got up early in our calculator. And write down A and B. A equals -239.8.07, and B equals 15.1934. With this, we're going to make the line y equals A plus bx. So I just plug it in. Y equals -2398.07 plus 15.1934x. Now we're going to use this formula to approximate, as was said earlier in the problem, approximate the death rate due to CHD of a person who is 171 centimeters short. Still a funny joke. And we say we're going to take 171 and plug in for x, which is over here. So check out that. So -2398.07 plus 15.1934 times 171, and that is going to equal 204.001. So that means that out of 100,000 people, it's safe to say that, or the line says that 204 of them, let me just get rid of those things. Yeah, 0.001 person. 204 people will die due to CHD. So, yep, that's my problem.